In this video, we are going to put together the functionality for our song class. So we'll jump in here directly into our methods. So we'll jump in first to the tick method. We'll have a public virtual method. It will have no returns, so we'll call it void, and the method itself will be tick. We'll take in no parameters to the tick method, and we'll set up an empty method body right out to the side.
Okay.
Now the purpose of tick is, since the song, one of the song's jobs is to track the passage of time,
right,
and remember where it's at. Tick will be used to indicate to the song that time has passed.
All right.
Now the idea is that the driving force, the driving time interval, will actually be set outside, since we're going to be setting our main game loop to operate at a subdivision of a metronome.
Mm-hmm.
So it's really the main game loop that will maintain timing. But every time our game updates, that information, or that you could say that event needs to get passed on to our song,
right,
so the song can count 1 unit of time has passed.
Gotcha.
And so we're calling that a tick. And the idea is that every time tick is called, the song can advance itself 1 unit forward in time.
So tick's going to end up being called externally by the game loop, is what you're saying?
Right.
Gotcha.
Indirectly, there's probably a series. The main game loop calling a game screen, the game screen calling.
Okay. Yeah. Calling it through something else.
Right. Also, since songs will be used in other screens such as edit mode recording, there'll usually be a series of update calls. But I mean, you're still correct in saying that the update method in turn ends up calling tick.
Okay.
The other thing is tick will also handle anything that happens as time passes, meaning the fact that we've advanced 1 tick might also mean that a note has just come into play, meaning
or has just been missed,
or has just been missed. So we might need to fire off note play or note miss, or if if we run into any other scenario, maybe like such as song ended or beat or so on.
Okay.
The idea, though, is that tick is not going to be implemented in the base song class, since different things will need to be considered in a game song being played back for gameplay versus a song that's being recorded.
All right.
Now, moving on from here, we have a method called pressNote. It'll be a public virtual void method. The name will be pressNote. And we will take in 1 parameter, an integer called track. And once again, we'll put an empty method body out to the side. Now, pressNote is the way that we'll pass input to a given song.
Okay.
Again, in the base song, it won't actually do anything, because this behavior will need to be defined by a specific type of song. In the case of a song being played at gameplay, we'll be hitting notes that already exist. And in a recording song, we'll be hitting notes and bringing them into existence by hitting them. The idea is that pressNote is how we indicate input to the song. And it's interesting to note that as a result of calling pressNote on a given song at a given time, we may get any one of the 4 node event handlers called. I guess technically one of the 3. Note play happens automatically as songs pass. So to be more specific,
hit, miss, or mispressed.
Hit, miss, or mispressed. Because if we hit the note and our cursor happened to be at a note that we hit, the note hit would get fired. If we call pressNote and there was no note within range, we'd call note miss. And if we called, if a note went past time, really that would be mispressed.
Yeah, if we were expecting a note to be hit but nothing was hit.
I mean, exactly. If we're if we skipped a note, we'd call note mispress. And if we tried to hit a note and failed, then we get note mispress. I guess technically it means only note hit and note mispress are really the ones being called, because note play always happens automatically. Note miss happens if you do nothing. So as the result of interaction, you would end up calling note hit or note mispress. But moving on from here, we've got a method called setCursor. So we'll make this public, virtual, void, setCursor. And we'll pass in a single integer parameter called value. So we'll pass in a new cursor value. Now, since this method is very simplistic in implementation, we'll drop in here with the actual functionality. SetCursor's job, as it would indicate, is just to take the cursor field and set it.
Okay.
So we have this dot cursor equals value. Now this brings up a few interesting questions. One, why not just use a property here? Because earlier we went through the effort of protecting the cursor field, and we did so using a read-only property. We could have dropped a write accessor to our property, but since the patterns can be, or excuse me, songs can be implemented differently depending on the kind of song that you're using, we wanted to leave this up to the specific implementation. And we don't have the concept of virtual with a property. So instead we're defining this here as a method so that, for example, a playback song could do something different on reset than a recording song.
Gotcha. Okay.
So, moving on from here, we have a method called reset. So once again we'll have a public virtual method, void return type. The name will be reset, and we'll pass in no parameters. Now reset is meant to get the song back to its initial state. For example, if we had already played through a song and we wanted to replay the same song, we would use reset to get the song ready. And now by ready we mean getting the cursor in the correct position and making sure all of the notes are in their original state. And there's a few pieces of information, state information, that can change note by note. So that means the first thing we'll need to do is reset the cursor. Now setting the cursor back to the beginning of the song seems like you would do something such as setting the cursor to 0, except for the fact that we have this value called lead-in beats, and the fact that we want to implement lead-in time in the song itself rather than in the note values. So what we're going to do is we're actually going to set the cursor to some negative value before 0 to give ourselves some time that has to play out before we hit the first note, which should be at tick 0. So in order to figure out how many ticks we should go before time starts, we'll take lead-in beats, but we need to find this value in ticks, because cursor is based in terms of ticks.
So we multiply that by ticks per beat.
Exactly.
And maybe set the whole thing negative.
So we could look at that as taking our ticks per beat. So we could look at the field this dot ticks per beat. Now if we just set it to ticks per beat, we would set our cursor to 1 beat into the song. We need to go the other way, and we also need to go multiple beats. So we'll multiply this by negative lead-in beats. So this dot lead-in beats. So again, if we left the negative off, the problem is we'd be going forward in time.
Right.
So for example, if we had 4 lead-in beats,
then we'd be 4 beats into the song
and we'd miss a measure of the song. If we do negative lead-in beats, then we'd be 4 beats before the song, and that would give the appropriate lead-in. Alright, the next thing we need to do is go through all of our notes and reset any of the notes that have been hit or missed. We're not going to affect their tick value or their track value, of course, because that would change the song. But we do need to make sure that if the song has already been played, we make sure that any hit or missed notes get reset. And we'll accomplish this with a simple for each loop. So I'll grab the for each template, tab out twice, and say that we will have individual variables of type note, and we can call those note, and we will be looping through the notes list. And we can look at that field as this dot notes. Now inside of our loop, as we're pulling out notes one at a time, we can take each note and tell it that its hit flag is set to false, and we can tell the note that its missed flag
is also set to false.
Is set to false. Since all the notes go back to pending, so that means they are neither hit nor missed yet. Alright, moving on from here, we can take a look at a series of methods that will be used to interface with the events. Now, what do I mean by interface with events? Because generally, we just define the events and then use them as necessary. With these events in place, we can let code that's going to be inside of tick or press note or any of the other methods fire off those events at will.
Right.
Now, the interesting thing is, of course, since they are marked as event, that means we will not be able to invoke them, well, outside of song. And that makes sense. We don't want external classes invoking any of our events. but that means we also cannot invoke them from a descendant class. And we've already said that we want to end up extending this into song play and song record. And song play is going to need to be able to use several of these. It's going to need to be able to use play, hit, and any of the other ones that might be necessary for gameplay.
So we're going to set up a group of protected methods that will allow us access to these events from descendant songs.
Exactly. We'll make a series of methods whose purpose is simply to invoke the events. So we'll call these trigger methods.
Okay.
And now, since these will be normal methods, we can use the protected modifier. And thanks to protected, we can then gain access to these events via any descending class.
But nobody else, just the descendants.
Exactly. So we can be specific as to who can invoke these events. So looking up here, we've got a series of events, and we'll set up one trigger method per event, beginning with beat. So we will make a protected method, void return, and we'll call this method trigger beat. Trigger beat is going to take in no parameters because a beat event is only going to need to take in the song instance. We don't need to have to pass that. We can just look at this reference to find the current song. So inside of trigger beat, we will invoke the beat event. Of course, beat is going to need to take in a song because it's a song handler. So we'll pass in this instance of the song. All right. Next up, looking at our series of events, we have ended. So we can make a protected method, void return, called trigger ended. You know, that sounds kind of funny. Trigger ended makes it sound like the trigger stopped. We could call this something like trigger end, and then saying that trigger end causes the ended event makes more sense.
Sure, yeah. You're triggering the end of the song.
So inside of trigger end, we will invoke the ended event, which once again needs a song instance. That instance will be given using this reference.
Okay.
All right, moving on from here, we have the note play event. So we can make another protected method, void return, called trigger play. Now let's look at the method signature of a note play event. So trigger play is meant to hit the note play. So let's invoke note play. And here we need a song. That's easy enough. We gather this using this reference. Now note, we need to pass in the note in question. In order to gather that, we'll pass it through the method itself. That means a descendant of song would need to call trigger play and then pass in the note to be played. That means here inside of our method signature, we'll put in a note parameter called note. Then inside of the note play event, we can pass note along. And looking at this, to make our method name match the event a little bit better, I'll actually call this trigger note play, just to keep it from getting confused with maybe playing or pausing a song.
Mm-hmm.
All right, what's next? We have note hit. So we could make a protected method, void return, called trigger note hit. And once again, since this is going to be a note handler, we will pass a note to trigger note hit to in turn pass on to the event. So then we can now invoke note hit, pass in this as the song, and note as the note. Alright, next up we should have note miss after note hit. So we will put together protected void trigger note miss.
Yeah, these are all kind of repetitive at this point.
Exactly, since it's all very simple code, it's just putting that extra layer of control around the event.
Mm-hmm.
So here, once again, a miss is a note handler, so we will pass in the note that was missed. And instead of here, we can invoke note mispress and pass along this instance of the song, and the inside of, actually I hit the wrong event, didn't I? Note miss, versus note mispress.
I think you did, yeah.
So IntelliSense was getting a little bit too friendly because they're right next to each other. So we're looking for note miss. There we go. Note miss to note miss. This instance of the song, and now the parameter makes more sense. Pass the note along to it.
Gotcha.
All right, one last method.
That's mispress.
This will be protected void trigger note miss press, where we will take in an integer for the track that we attempted to hit. And then we can turn around and invoke note mispress, this instance of the song, and we will pass track along to the event. And there. So we now have trigger methods for each of our events, giving ourselves protected access to any event invocation.
So we added methods for tick, for press note, set cursor, reset, and then trigger beat, trigger end, trigger note hit, trigger note play, trigger note miss, and then trigger note miss press.
Exactly.
All right.
So with this series of methods in place, that takes care of our base song class.
Now, what's going to inherit from our base song class?
Well, two classes.
Mm-hmm.
We will have a class called song play.
Okay.
And song play is used, it's going to be used inside of the actual gameplay, and it's going to be used inside of the edit mode. A song play class is going to read the passage of time and cause notes to play as time progresses.
Okay.
So song play is intended to take a set of already recorded notes and cause them to, in conjunction with a renderer, move across the screen of the track where we are throughout all these notes. And it will actually be the playback song that's going to contain our hit detection threshold. So we're actually going to make a subclass of song where when we implement note press, we put together some threshold calculations.
Which also means that each individual song could have its own threshold.
Technically, yes. As you go song by song, you could set that.
If you wanted to. So what else is going to inherit from song?
One other class, and that's going to be song record. Song record is going to focus on a completely different implementation of note press.
Sure.
Instead of looking for a threshold to check existing notes, it's going to start with a completely blank song. And every time note press is called, it's going to drop a note onto the track given.
Gotcha.
So in that case, it's not going to be looking for existing notes. It's going to take in a note and then drop that note. Basically, it's going to take in a track, figure out what note that would be, and drop it into the notes list.
And the great thing here is that we've already set up a basic functionality system that will support playback and recording.
Right, so all from this one base song class, we can implement a lot of very different functionality in different classes.
All right. Was there anything else you wanted to add, Logan?
No, I think that brings everything together. Again, we have all of the base information, both in data and in functionality, that our songs are going to need to maintain and share.
All right. Well, then that's going to wrap things up for this video. Thanks.